I will take the attendance in the last. Okay, don't leave the meeting. So in the last class, we have discussed about the analog instruments. The measuring instruments are classified into mainly how many types of measuring instruments are there? The measuring instruments are mainly classified into. Is it audible or not?
Yes, sir.
Measuring instruments are classified into how many types? Instruments are classified into 2 types. Very good. Next, what are those 2 types? What are those 2 types?
Absolute and secondary.
Very good. Absolute instrument and secondary instruments. The absolute instruments, actually those which will not give the direct measurement, they will read the meter in the meter parameters only. Okay, in the meter parameters only we are going to get the readings. So later we have to calculate that one, analysis we have to do that one. But the secondary instruments, directly they are going to give the whatever the requirement is there, particular instruments are there, those instruments are called secondary instruments. We are going to call over there. Next, the secondary instrument is again classified into how many types?
3 types.
3 types. Very good. What are those 3 types?
Indicating instruments, recording instruments, and integrating instruments.
Very good. Indicating instruments, recording instruments, and
integrating
instrument. So indicating instruments are also called as analog instruments. We can call that one. So they are going to just indicate the value, or in the predefined scale or calibrated scale, they are going to just indicating the values of the measuring quantity. And the recording measure instruments, they are going to record the value per particular time. For 11 a.m. how much was there, 12 a.m. how much was there, 13 a.m. how much was there, like that they are going to record that one. But the integrating instruments, actually they are going to give the quantities with respect to time or particular period of time. They are going to give for 1 hour how much we have consumed or generated, like that they are going to give that. So these are the 3 instruments, but according to the heading of your second chapter, that is analog instruments, only the indicating instruments we are going to concentrate much here now in this chapter. So we will start the indicating instruments. The indicating instruments are consist of mainly the essential for the indicating instruments are calibrated scale is required and one pointer is required for that one. So the pointer is attached to the moving system, which will come into the moving system, and bearing systems are there. So the moving system is subjected to the 3 torques over there. The moving system consists of 3 torques. Those torques are forces are deflecting torque, controlling torque, damping torque. So the deflecting torque, which will helps to move the pointer from zero value to the measuring quantity or the value which is required or to going to operate that one. So for that reason, the deflecting torque is also called as operating torque. We are going to call the controlling torque. It is going to control the value. It should have to come back to the zero from the non-zero value after removing the supply and all the things. So the controlling torque is called as restoring torque. We are going to call. In between this deflecting and controlling torque, the fluctuation is there. So oscillations are there. To damp those oscillations, we are going to here the damping torque we have to produce. So that is called damping torque. We are going to call that. So one by one we'll discuss now. So this is the for the deflection. We are going to call that one. Just a minute. The screen is visible.
Yes, sir.
Hello participants to unmute. Some people are using annotate. For that reason, I will remove that one. Which slide is visible to you people?
Yes, sir.
Which one? Which one is visible?
Essential of indicating instrument.
That one only it is visible. Huh? Okay. Someone is disturbing. Actually, we'll do that one. Okay. So we'll start the deflecting force. Will start that one. So the deflection, it should have to give initial condition. At the initial condition, what will happen here? So the pointers, this is the predefined scale. This one, whatever the scale is there, this complete part is scale we are going to call here now. From here, you can call this one as 0, 1, 2, 3, 4, 5, like that. We can mark the numbers over there based on that one here now. Calibrated scale also, we are going to call that one. This is the pointer which is attached to the bearing and the moving system is there here. Okay, so at the initial condition, the pointer will be at 0 position here. The pointer will be at 0 position. But by providing the supply, the pointer will start from this position to the towards this one here. So 0 value to the non-zero value, it is going to move that one. It is going to deflect that one. It is initially constant position, but it is going to deflect or it is going to operate that one. So for that reason, deflecting force is called as operating force. We are going to tell that one here. Deflecting force or deflecting torque is also called as operating torque here. When there is no input signal to the instrument, the pointer will be at 0 position. कुछ भी input नहीं है तो वो 0 position में रहते. Pointer will be at 0 position. I will draw side by here also. Okay, this is the scale is there, the pointer position I will draw here. This one is the pointer position here. At when there is no input at all, on that time the instrument, the pointer will be at its 0 position. Next, to deflect the pointer from its 0 position, a force is necessary, which force is known as deflecting force. A pointer, either say 0, say whatever the values it is there, it should have to move from that one to operate that one here. So to operate this pointer, some force is required. That force we are going to call as, that force is known as deflecting force. We are going to tell that. So the deflecting force is produced by making one of the magnetic, heating, or chemical, or electrostatic, or electromagnetic induction here. Any method. We can magnetic field method, we can consider that one by heating that one. Also it will be very chemical reactions also, you can do that one by using electrostatic and electromagnetic induction, also effect of current or voltage here. Electromagnetic induction, effect of current and or voltage here. Almost we are in the electrical system, we are going to use this electromagnetic induction effect of current or voltage method we are going to use here. So this will cause the moving system of the instrument to move from, or shift the pointer from 0 position to the non-zero value here. So the effect of current or voltage and cause the moving system of the instrument to move from its 0 position. 0 position से आगे move होने के लिए help करता है. That is called moving system efforts or working we are going to call. A system, a moving system, it will help means it has created the deflecting torque here now. The deflecting force is created here now. A system, this system which is going to produce the force, deflecting force, that system is called deflecting system. We are going to tell that one. So a system which produces the deflecting force is known as deflecting system. Which system will produce the deflecting force or deflecting torque? That system is known as deflecting system. Generally, a deflecting system converts an electrical signal to the mechanical force here. What is the input we are giving here? For the emitter is there. Emitter को आप input क्या दे रहे? Current दे रहे. Yes. We are giving the electrical supply. Supply we are providing to the emitter. But वो reading कितना है बोल के कैसे? This pointer is going to move that one. So one pointer is moving from one place to another place is nothing but that is mechanical energy. Yes. So generally this deflecting torque or force or system, it converts electrical signal. Input is given as electrical signal. Current is given here now. Voltage, current here now. But the output is the mechanical force is produced, which will move the pointer from one place to the another place. So this is the operation of deflecting force functions we have discussed here now. See here, I told that one magnetic effect ho sakte, electromagnetic effect and all the things I told that one here. So this diagram is not visible. Let them here. See the magnetic effect here now. Here one coil is there here now. One coil and one fixed magnet we are going to use here now. This is the natural magnet. This is artificial magnet we are going to call that one here. Some iron core material is wounded by a coil, which is nothing but whenever you give the electrical supply, it acts as a magnet. That is the property of electromagnet. We are going to call that one. Magnitude nahi, magnetic effect we are going to call this one. When the current passes through coil, this one, the current direction here now. Here, I will take the annotate just a minute. See here, this is the iron core is there. Actually, inside this one, this line is not visible clearly. This is the iron core. Material is there. I will wound the wire on that one here now. The wire is fixed on this core material here now. The iron core is wounded by a coil, current carrying coil here. This is the coil is there. इसके ऊपर wire shift किया है. Okay. So when current passes through this coil, through a coil, a current pass होगा this coil. In this coil, it will flow like this. Current will flow like this. Okay. Produces imaginary bar magnet here. Now, imaginary means it is not a fixed magnet. Whenever the current will flow, then only it will act as a magnet. When the soft iron piece is brought near to this coil here, now it is acting as a magnet now. When the iron piece is bring near to that one here, now it may attracts or repels, but based on that poles here now. The magnet, it has two poles, north and south poles. Whenever the current enters here, no, that pole is nothing but north. Leaving point is called south here. No, here south pole is there, here north pole is there. What will happen here? No, attraction or repulsion? Opposite poles attract each other. Same pole repels each other. Here south pole is there, here north pole is there. So whenever we'll bring the iron piece near to this coil or imaginary magnet bar, it is going to attract here now. It is going to attract. Depending upon the current direction, the poles are produced. Here current is entering north here now. Suppose either current enter hoga to ye north ho jayega, north and north it will repulse each other. They are going to repel each other if the based on the current direction we told that one here. So produces in such a way that there will be force of attraction between the coil and soft of iron piece here now. Here north pole is there, here south pole is there. South and north here both will attract each other here now. So this principle we are going to use in attraction type moving iron instrument here. I told in the syllabus PMMC, permanent magnet moving coil instrument is there, moving iron instrument is there. Moving iron instrument is again classified into two types, that is attraction type and repulsion type. So this principle we are going to use in the moving iron instruments here. If the poles are same, then it will attraction will occur here. Now based on this principle, attraction type instruments, suppose this is the north, this is the south, then north and north it will repulse each other. Those repulsion type instrument we can use that one here. Is it clear? This is a simple funda you have studied in the first year, common for all the branches. The diploma first year also we were studied this one. It was common for all the branches. Can I proceed for the next slide? Nobody is replying. Is it audible or not? I'm getting a doubt actually.
Yes, sir.
Okay.
Yes, sir.
Next, we will go for the next slide. That is called force between a permanent magnet and current carrying coil. Instead of here, what we have used, one iron bar we have used. Iron bar we have used. Instead of this one, I will use one permanent magnet I will use here. Here, the permanent magnet is there, but we will use the one current carrying coil. We are going to bring near to that one here. Based on that, how the force will be produces in between them, we are going to discuss here. This is one current carrying coil and one permanent magnet we are going to use. So when a current carrying coil is placed under the influence of magnetic field here now, a magnetic magnet hai to iska surrounding magnetic field will be there. If the magnet is there, then surrounding the area it has some magnetic field. Whenever a current carrying coil will bring near to that in that magnetic field, the force of attraction or repulsion will be occurs. Yes or no? Force of attraction or repulsion process will be occurs over there. It may attract or it may repel. Both will produces the force only, na? It will produces the force only here, no? So when a current carrying coil is placed under the influence of magnetic field here, now field produced by the permanent magnet, a force is produced between them here now. That force will be either a force of attraction or the repulsion here now. If the coil is mounted on a spindle between the bearings, ये coil है ना, इसको मैंने bearing बिठा के इसको spindle पे connect कर देता हूँ. Then if because of this force of attraction or repulsion, it may rotate or it may move away from that one, it may attract that one, some mechanical force will be produced here now. So there will be a movement of the coil. If the movement of the coil is there, so this effect is utilized in one instrument, that is called here. What is there here? What is this one? Permanent. This one is permanent magnet. This is the coil. It is in the moving position or in the permanent position. This one here, permanent magnet, moving coil here. No. So this one PMMC instrument, we are going to use this principle here. We are going to use this principle in the PMMC instrument. Is it clear? So next one, that is called force between two current carrying coils. Instead of this one, when two current carrying coils are placed closer to each other, there will be a force of repulsion between them. If one coil is movable and other is fixed, the movable coil will move away from the fixed one. This principle is utilized in the electrodynamometer here. This diagram is actually error is there. So what we will do, just a minute. Wait a minute. Okay, so this is permanent magnet moving iron instrument. We are going to use this principle. Suppose if instead of this magnet and instead of this iron core, I will use two magnetic coils. I am going to use this one. The same coil, two coils I am going to use over there. How we can use that one? I will draw the diagram. Actually, this diagram is corrupted. That one. I will draw this one. This diagram is corrupted. Na? So instead of this one, I will take here now one coil. I am going to consider here now. This is one coil. So I will make the winding for this one. Two coils. Instead of one coil, we can use two coils here now. Both the coils will carry the current. Both the coils will be carry the current. Okay, this is one coil. Another coil I will draw near to that instrument only, near to that one coil only. So here I will write like this. Okay, this one. Here the current is entering here now. Here the current is entering here. So what I told, the current entering point will be, current entering point will be south or north? I'm asking to you people only.
South.
South. Current leaving point will be? Current leaving point. Current leaving point will be the entering point north to south here now. Here the current is entering north to south here now. So both the coils are here, the south pole is there, here the south pole is there. Okay, it will repulse each other or attract each other?
Repulse each other.
Repulse each other here now. So this principle we can use here. In that one, we can one coil we can fix that one, another coil it may be movable over here now, or in between these two another coil also we can use that one here now, another current coil also we can use that one here now. So when two current carrying coils are placed closer to each other here now, Here, this is also current carrying coil. This is also current carrying coil. These two are kept closer to each other here. Now, there will be force of repulsion between them here. Now, force of repulsion is there in between these two here. Now, if one coil is movable and other is fixed, the movable coil will move away from the fixed one. Suppose this one is fixed one, this one is movable here. Now, whenever we will bring near to that one, because of this same poles here, it is going to repel each other, and it is this one, it is going to move this coil here now. So this principle we are going to use in the electrodynamometer type here. Mainly, I told in the second unit how many instruments, how many devices we are going to study. I told that is PMMC, moving iron instrument, electrodynamometer. These three instruments are very important. I told that one for the measurement of voltage, current, and power. So for all these three instruments, we are going to use one principle here. Now here both the coils are there. We are using both the coils for the electrodynamometer. I will show that one. For the PMMC, what we are going to use? One permanent magnet, another one is moving coil. This is the permanent magnet. Moving coil we are using for the PMMC. For the moving iron instrument, one is iron core, another is coil we are going to use here. The permanent magnet or coil, one is one moving iron we have to use here. Now the name itself, it indicates that one moving iron. So iron part we are going to use here. Moving iron, moving coil, and two coils is nothing but electrodynamometer. We are going to call that one. So this will help for the deflecting torque or deflecting force here. Now, if you have any doubts up to here, you can ask me. Any doubts? I'm asking to you peoples only. We have to reply.
No, sir.
Okay. Then we'll go for the next topic, that is called controlling torque, controlling force. We are going to tell this one. Actually, this one. We are going to use this for the two methods, two reasons we are going to use this one here. To make the measurement indicated by the pointer definite is nothing but constant. Okay. To make the measurement indicated by the pointer, a force is necessary which will be acting in the opposite direction of the deflecting force. First, ये समझ में आ रहा है तो आप लोगों को deflecting force समझ में आया तो this will become easy. If you understood deflecting torque, then it will be easy for you peoples. Okay, this is the scale. Deflecting torque, what will happen? What will do? If the pointer is at this point here, already it has left the pointer here. Now the pointer is at non-zero value here. So it is the constant position, it is there here. So the force is necessary which will be acting in the opposite direction to the deflecting force here. Now the deflecting force is moved from 0 to non-zero value here. Okay, that force, which force will act opposite to the direction of the deflecting force, that force is called controlling force. We are going to call that one here. So to produce this controlling torque or force, a system is there again here. Now that system we are going to call as controlled system. We are going to call that one here. The effect, which is the force which is going to produce opposite to the deflecting force, that is known as controlling force. The system which will produce the controlling force, that system is called controlled system. We are going to call that one. A system which produces controlling force is known as controlled system here. So the main functions of the controlling systems are one and two functions are there here. First one, it should have to produce a force which is equal but opposite in direction to the deflecting force. Deflecting force kitna force produce kiya tha, same force it should have to produce, but the direction should be opposite to the deflecting force. Deflecting force kitna hai abhi? 0 to, suppose I will consider this one as 10 here. 10 I will consider here. This is the deflecting force here. So when the controlling force, it should have to produce same 10 here now. Initially this is 0 minus 10. 10 minus 0, how much it is? 10 only. Yes, 10 minus 0, how much? 0 से 10 गया था अभी pointer. In the controlling force, what will happen? From 10 to 0, it is going to give over there. So both will be 10 only. Both the value will be 10. Controlling force equal to 10. Deflecting torque force equal to also 10. Yes or no? I'm asking to you people only. Give the reply.
Yes, sir.
So the
sir.
deflecting force or torque is also 10. The controlling torque is also 10. The magnitude is 10. But what is the direction here now? What is the direction?
Left to right.
Left to right and right to left is nothing but 0 to non-zero, non-zero to 0. Both the torques or forces are opposite in direction. Here 10 minus 0 is there. For this one, initial value is 10, controlling torque, but the final value is 0. So 0 minus 10 here now. For the deflecting torque, this is plus 10. For the controlling torque, it is minus 10. So the plus and minus, it indicates that it is direction is opposite. Yes. Here, to produce a force, the first function of the controlling system is to produce a force which is opposite to the deflecting torque or deflecting force at the final steady position of the pointer, in order to make the deflection of the pointer definite for a particular magnitude. Same magnitude, it should have to deflect or reverse go back here. No movement. In the absence of controlling system, the pointer should swing behind the final steady position of the magnitude, and thus deflection will be indefinite here. Suppose example I will tell that one. एक इंस्ट्रूमेंट है, उसमें both deflecting force है सिर्फ, there is no control at all. Then suppose what I will do, आप लोग सब लोग एक छोटे बच्चे के टाइम पे बलून खेला है ना, आप बलून को ऐसा रबर करके हाथ को मार दिए तो आगे जाता था, पीछे आ जाता था. यस, एग्जांपल देता हूं मैंने अभी. All of you have played that one. Balloon hitting the balloon, it will go away, and because of that rubber, it will come back to hand. It will hit to your hand. All of you have played this game.
Yes, sir.
Yes, sir.
Yes. Okay. Suppose आपका हाथ में rubber नहीं है, then if you touch it, hit it, that ball means it will go away from that your hand.
Yes,
It will
sir.
come back. It will come back to you.
No.
No. Like that, if the controlling torque is not there, then because of the deflection force, what will happen? Because of the deflection, it will swings over there. It is not definite. किधर stop होना है, उधर stop नहीं होते हो. Deflect controlling force नहीं है तो. So for that reason, the stop करने के लिए क्या चाहिए आपको? हमको हमारा हाथ में रबर चाहिए उसको controlling back करने के लिए. किधर तक मारना है उतना ही जाना है, उधर से वापस आना है. Like that, the controlling force is there. If without rubber, it is only deflecting torque. With rubber, we are playing a balloon, that is called deflecting torque is there. Hitting the balloon, that is deflecting torque. Bringing back to your hand, that is called controlling torque. We are going to call that. Is it clear? Now, that is the one function. One function, we have to create definite deflecting torque. Definite means either जाना है तो इधर ही जाना है वो. Because of controlling torque only it is possible. That is the one function. Another function, we have taken the reading and removed the supply, but the pointer is not coming to the zero. Zero को नहीं आया जाएगा, उधर ही रुक गए तो. That is also problem. So we have to bring back the pointer from the non-zero value to zero value. That is the second function we are going to call that one. Second function of the controlled system here. Now, to bring the moving system back to zero when the external signal to be measured by the instrument is removed. I will remove the supply, then it should have to come back to zero. If there is no controlling force or controlling torque, it will not come back to the zero over there. So the pointer should return back to zero position here. This is possible due to because of only controlling force only. So that pointer will be indicating a steady value when the deflecting torque is equal to the controlling torque. Deflecting torque is equal to the controlling torque. Just a minute, someone has signed out. Here. So understood? Mainly the controlling force, we have, it has two functions. The control system has two functions. One is to produce the force which is equal and opposite to the, equal in magnitude but opposite direction to the deflecting torque. So that is which will give the definite control, definite deflecting force. If controlling torque is not there, then the whatever, because of the deflection, it will swings away from that particular definite value. It may become undefinite. We are going to call that one. Okay. For that reason, first is the controlling force is required. Second one, if we have removed the source or supply of that instrument, it should, the pointer should have to come back to the zero. So to bring back the pointer to zero, the controlling force is required here. Now, from these two, discussing these two forces, what we have understood here, TD is directly the control, deflecting torque I will consider as TD, controlling torque I will consider as TC here. No, so both the magnitudes are same only, TD and TC equal to, both are equal here. No, yes, TD minus TC equal to 0, you can write. Yes or no? TD minus TC, we can write 0 here now. TC equal to, suppose TC equal to 10 hai, TD equal to minus 10 ho jayega. So this is minus 10, minus minus plus here. Now it will become 0 only, na?
Yes.
So from this equation, we can write TD equal to TC, we can write here now. Yes?
Yes, sir.
So from these two discussion, we can say that the deflecting torque is equal to the controlling torque, but the direction is opposite. Remember that. So one more thing I will tell that one. See here, the pointer is deflecting from 0 to non-zero value here. Because of what here now, electrical signal we have given here now. Because of the current, the pointer is deflected here now. That is called theta. We are going to call here. Same theta, it will come back here now. Theta is nothing but deflection here now. Angle, how much angle it has deflected here now. So the second point, that one where we have stopped here now, this one. This is possible due to the controlling force, and the pointer will be indicating a steady value. When the deflecting torque is equal to the controlling torque, then only the pointer can give steady value here now. Steady value. ये एक remember करो, balloon का और rubber का game remember करो. अभी damping force is very important than these two. If you understood these two forces, then only you will understand the damping force. Then only you can understand the damping force, you can understand that one here. So for that reason, the balloon example I have taken here now, it is applicable for the deflecting force, controlling force, and even it is applicable for the damping force also here. Okay, so the controlling force, we are going to, how we can control that one. The suppose deflecting force kaise kar sakte humne, because of electromagnetic inductions and all the things, by providing, giving the electrical signal, it will give magnetize here now, and it is going to move that one. But how can control that one? Like a rubber to the balloon, you can control. That is the spring method is there here. Actually, we can use the spring here. Any spring you use that one in your childhood or anywhere. You can small vehicles, whenever you will push that one, it will backside, you will take that one, the spring will be, it will extract that one, it will, okay, it will merge that one. Suddenly you remove that one, means the spring method here, we can control that. So like that, in an instrument, we are going to provide one spring, that one spring. It can stretch and it can shrink over that one there only. So this part will continue in the next class. This part will continue in the next class. Just a minute, I have not taken the attendance for that reason. Meeting is delayed. The spring control methods, and one more is there. We'll discuss in the next class. With the diagram is there for this one. So this is the spring control, how we can control by using the spring and all the things, and damping force. These all the things we'll discuss in the next class. Rule number 1, 2. You give your attendance, otherwise I will put absent. Remember. Rule number 1. Unmute and say yes. 2, 3,
Present, sir.
4,
Present, sir.
5,
Present, sir.
6,
Yes, sir.
7,
Yes, sir.
8,
Present, sir.
9,
Present, sir.
10, 11. Roll number 11, 12,
Yes, sir.
13, 14,
Present, sir.
Yes, sir.
15,
Present,
16, 17, 18,
Yes, sir.
19, 20, 21, 22,
Present, sir.
23,
Present, sir.
24, 25, 26,
Yes, sir.
27, 28,
Yes, sir.
29,
Yes, sir.
30,
Yes, sir.
31, 32,
Present, sir.
33,
Yes, sir.
34,
Sir.
35,
Yes, sir.
Present, sir.
36,
Yes, sir.
37, 38.
Yes, sir.
Absent numbers, I will tell that one. You confirm that one. Roll number 1. Roll number 2 is absent. Roll number 11 is absent. Roll number 16, 17, 19, 20, 21, 25, 27, 31, 37. इसमें कोई है तो बोल दो. Once again, I will repeat. Roll number 1, roll number 2, roll number 11, 16, 17, 19, 20, 21, 25, 27, 31, 37. These are the absent numbers. Okay, you can leave the meeting.